The example we're going to see now is a very fun problem, a mathematical problem, which is named after the mathematician that proposed the conjecture, the Collatz conjecture. The conjecture is that if you start with any number, any positive number, and you follow the steps that we will see in a little bit, then no matter what, the last number of the sequence produced will be the number 1. Now, what is this process that we will be following? We will take this number n. If n is even, we will divide it by 2. If n is odd, we will multiply the number by 3 and add 1. And we will be repeating this process with the new value of n that we have produced until n, as long as n is greater than 1. So you can see a while loop there. Again, the Collatz conjecture is that the numbers that will be produced in this sequence will end up always with the final one being 1. What we want to do is to count the number of values in the sequence and return this number. In the implementation that we will see, we have also printed the number in the sequence, but you don't really need to do that for this particular problem. We will use a class that will be named Collatz, after, again, the mathematician that proposed this conjecture in the 30s. And what we want is to implement this algorithm in a method that will return to us an int, the count, and it will take as a parameter the particular number that we're starting with. You can play with different values of n and see that they will always result to 1. In our implementation here, there are no big surprises. We have our method, the count method, and then we have the while loop, where we will be repeating the steps of the algorithm. And what are those? We take the number n, and if that number is even, then we divide it by 2. Otherwise, we do what the algorithm says. We will multiply it by 3 and add 1. When are we going to stop the process? When n becomes less than 1, less than or equal to 1. Now, the c variable is what we will return, so every time we execute one step of the algorithm, we are increasing its value. The print statements, again, they are not necessary, they were not asked from the definition of the problem. We have put them there because it will be fun to see the sequence of numbers produced. And as you can see in the main, we're just checking 3 numbers. What happens when we start, for example, with 22, with 1, or with 1000? And we can now go and run the problem and see these sequences. You will always see that the very last number will be 1. You would just see the numbers that we started with, and of course they not necessarily go down. For example, we started with 22, but we also have 52 here. And remember that when n is odd, then we are actually increasing its value. And also when we start with 1000, you see a really long sequence that, again, it has as a very final number 1. It's a sequence of 112 numbers.